Kia ora, everyone, and good morning. Thank you so much for joining us today. I'm Nisha, the training lead at NeSI. My role focuses on facilitating all things training, all training efforts that happen at NeSI. So I'll begin quickly with a round of housekeeping rules for the day. So just the usual, if you've come to any of our previous training events, you know the drill is just to keep your microphones on mute, just so we minimize any sort of background noise, and we let the host or the speaker go through the webinar without any sort of echo or glitch at the audio glitch at the background. So please do mute yourselves. For any questions that you may have during the course of this webinar, please use the Zoom chat function, and Alex and I would make sure to moderate those questions as they come in, and Hilary will answer them at the end. After his presentation is done, he'll go through the questions or comments. And please do turn on your cameras if possible. This is just something that we say in every training event, just so the speaker doesn't feel quite lonely going through the presentation. So if possible, please do turn on your cameras. And just as a reminder, this webinar is being recorded, and you will get an email shortly after this webinar with the link and the recording to the link, and other links that we send through as well. So yeah, just a heads up. And today's webinar will be led by Dr. Hilary Oliver from NEVA. And just a quick introduction to Hilary, for those of us who may not know him. Hilary Oliver is the principal scientist and research software engineering at NEVA. He trained in astrophysics before joining NEVA's meteorology and remote sensing team. Hilary started work on Cylc, which is what we are going to be talking about and finding out more about today, about 10 years ago, to implement a much more efficient way of managing cycling workflows in production weather forecasting systems. And Hilary wants to make sure to make a note that this is not, Cylc is absolutely not specialized just in weather forecasting. That's what we're going to find out. That's what this webinar is all about, to find out in what other ways you can use Cylc. He also helps to chair the technical advisory group of the Unified Model Consortium, institutions that use and develop the UK Met Office atmospheric model around the world. Currently, Hilary is leading the ongoing developments of Cylc as an open source project. And before Hilary officially takes on and begins today's webinar, I'd like to hand over to Alex, who's going to brief us on some quick introductions on workflows, among other things. Thank you.
Yeah, great. Thank you, Nisha. I'm going to share my screen here. Yeah, okay. So let me just start from the start here. Yeah, I'm really thrilled to sort of assist Hilary. I mean, I haven't done very much in terms of workflow, but I start to see the workflows as being really important as part of our consultancies. And I want to share with you, some of our experience, which we gathered. So we have these NeSI consultancies where we're helping scientists run better and faster on NeSI platforms. Now, one of the things that we need to remind ourselves is that the cores are not getting much faster. So it used to be maybe 15 or 20 years ago that if you buy a new computer, you buy a new CPU, then your code would sort of run twice faster every 1.5 years or something like that. That was known as being Moore's law. But that stopped. And what I'm showing here on these graphs, so ignore, the details. I mean, I understand that maybe you're not going to be able to see all the little labels, but you have that curve here, which is sort of the dark blue one, which flattens out. And that curve here, it flattens around the year 2003 or so, and it represents essentially the clock frequency. The clock frequency of a core CPU was the way we would get, faster execution speed on our code. And we didn't have to do anything. We could just sit on our bum and just wait, for the next CPU to come out, and suddenly the code was running faster. That's no longer the case. So the main message here that I have for everyone is that you want to run more stuff, you want to execute bigger tasks and so forth, you will need to run in parallel. And you have a certain number of mechanisms to do that. You can offload to the GPU, you can use multi-threading, you can apply MPI, you can, but you can also run jobs in parallel. And I think that's the main message that I want to convey to you. Or you can do all of the above, which of course that's the way for you to scale up. So now, how do we run jobs or tasks in parallel? So I'm going to use the term task because that's a little bit confusing. Task is sometimes used in the context of MPI, but here it's really in terms of jobs. Well, you can manually submit a large number of jobs, but that doesn't scale up. But works, you know, if you have 3-4 codes that you have to run in a sequence. But you can also write a bash script, which runs processes in the background. And that's how many people start. It turns out that this is getting quite complicated. And that was, as I understand, the reason why Cylc was created in the first place. That, you know, people had created these huge bash scripts that were very difficult to maintain. You could also use Slurm job arrays, or you could use a workflow manager. And we have SnakeMake on NeSI, we have Cylc, and some people are using Nextflow, which I don't have much experience. But this is very much like playing music. I mean, if you have a band of 4 people, then you don't need a conductor. If you have, you know, 50 people, 30 people or so, then it really pays off to have a workflow manager running. And so the typical pattern that we see at NeSI for scientists is that they have job 1, 2, and 3, and N, and so forth, and they run those in parallel. And this could be a calibration, it could be a parameter study, or something like that. And then at the end, you want to assemble all these steps into one, something like a summary statistics. So that's something that we see quite a lot. And all these jobs 1, 2 to N can actually run potentially in parallel, depending on how many, you know, slots are free on your platform. So here are a couple of consultancies that either could have used a workflow manager or have used a workflow manager. And they range from machine learning applied to weather forecasting and precipitation, to looking at traffic patterns, to looking at changes in landscape, and looking also at you know, species distributions and so forth. And there was one in particular which was, I think, the first a consultancy where we used Cylc, and that was a couple of years ago. And this is the one that is underlined here, but you can see sort of the jobs and their execution time. And you can see that they're all over the place. You know, some run very, very fast and some take a long time. And this was a scientist who had to wait, was doing post-processing of climate data, and had to wait for a week, essentially, to see his statistical results emerge, you know, the increase of global temperature and things like that. And that was, of course, taking way too long. And so what we did was we submitted all these tasks here through a workflow manager, which was Cylc at that. It was an older version of Cylc. And then the researcher was able to run, instead of waiting for a week, basically just a few hours. And the marvelous things with that approach is that it automatically takes into account or takes care of the load balancing issue. You know, if you're doing MPI, if you're familiar with other technologies, this is something that kills you scaling. The workflow approach does not have that issue. Essentially, you know, a worker, basically you have a node or you have some processors that have finished the job. Well, they're ready to get the next one. So it's really like task farming. So this is where I would like to stop and hand over to Hilary, who is going to tell us much more about Cylc. And so over to you, Hilary.
Thank you very much, Alex and Nisha. Hi, everyone. Let me just share my screen. Right, apparently you can now see my screen. Right, let's get started. I'm going to try to give a bit of a presentation and also a live demo. So we'll crack onto it. If this devolves into chaos, that's my responsibility, not NeSI's. You can take that into account in your feedback after this. All right, so this is really aimed as an introduction to people who haven't used Cylc. And as such, it's not a hands-on workshop. I'm not expecting you to come out of this being able to use Cylc immediately, but what the aim is to show you how easy it is to write and run small workflows with Cylc, and how easy it is to scale them up if you need to, and to give some pointers to more advanced capabilities. Now, one thing worth noting here is this is about Cylc 8. Cylc 8 is actually a new system. It was 4 years in the making. If you've looked at Cylc previously, you might want to take another look, because Cylc 8 is very different and more powerful and easier to use than the old system. And this seminar is not going to talk about differences between Cylc 8 and earlier versions. Right, so I'll cover where can I get help, what kind of a workflow engine is Cylc. It's very easy to write small workflows in Cylc. It's easy to scale them up, and I'll give a quick demo. Right, where can I get help? So we've got a website, cylc.org. That can be your first stop if you need help. That's what our website looks like. The front page has a fairly comprehensive sort of list of features and capabilities you might want to read, and some links to references. And at the top, the documentation link will take you to our online documentation, which has been massively revised, and a very comprehensive user guide there. So that's the online documentation. We also have an online forum where you can post questions about Cylc. Looks like that. NeSI has some new information on the NeSI support page. And Cylc is a Kiwi-led open source development project. As I said, that's all done on GitHub. Right. Now, super easy to get started with Cylc 8. On the NeSI HPCs, Mahuika and Maui, it's available already. You can play workflows out of the box. Unlike older versions of Cylc, Cylc 8 you can install yourself on your own laptop or whatever if you want to play with it from CondaForge. And it will run on a single VM out of the box. Yeah, there is some configuration involved if you're running if you're the administrator on a cluster, an HPC cluster, but not if you're running it on your laptop. So what kind of a workflow engine is it? Well, basically, it's designed to automate what you do on an HPC system or Linux, or even Mac OS. What do I mean by that? Well, you run commands and you manage processes, you move files around, that sort of thing. You submit jobs to a resource manager like Slurm or PBS, Slurm on the NeSI systems. And Cylc does that for you. More specifically, it runs lightweight distributed application workflows. By application workflows, I mean each task in the workflow, A, B, C, and D here, is an independent application, a command or a script or an executable, and Cylc can use those. They don't have to know, those programs don't need to know they're being co-opted into a workflow. In Cylc, you specify dependencies between tasks. You say, these are the tasks I want to run, and they depend on each other in this way. You don't specify inputs and outputs. Reason for that, dependencies in Cylc are very flexible. They can represent anything. It's often or usually data, but it doesn't have to be. And it allows you to see the structure of your workflow very easily. As Alex said, you'll automatically get the maximum concurrency allowed by dependencies and external resources. Like, for instance, in this little example, colored example here, I don't have to tell Cylc that you can run B and C in parallel or B and D. Cylc's just going to know that because B does not depend on C. So if it happens they become ready to run at once, I can run them together. Same with B and D. Cylc is aware of HPC clusters in the sense that it knows how to deal with the shared file system for installing workflow files. It can run schedulers across a pool of hosts for load balancing, and it can run jobs, of course, over multiple hosts. There's a whole lot of stuff which I'm not going to get much into today because we won't have time to do with robustness needed by production systems where Cylc is used. Recovering automatically from all sorts of failures. You can make your workflows do that. And Cylc has essentially manual intervention superpowers. If things go wrong, you can intervene in your running workflow to kill jobs, re-trigger jobs, do all sorts of things. A whole lot of advanced stuff. Again, we can save this for future workshops. Perhaps if people are interested, there's a possibility we could run those. Right, user interfaces. You can do everything with the Cylc command line interface, and it's got built-in help, as you can see there. But we also have fairly sophisticated web UIs and a terminal UI. This is what the web UI looks like for Cylc 8. Don't worry about the details. I will try to...
Microphone test.
Okay, somebody did a microphone test. Yeah, don't worry about the detail. I'll try to get to this in the demo later. But basically, on the left, you've got a list of your workflows, and we happen to be looking at demo/run 2, and this shows the various views of the state of the workflow and the tasks in it. The icons represent task and job states, and here we've drilled down to job details of this particular job. Shows where it's running, what the job ID is, how it was submitted to run, start and end time, outputs, and so forth. And this is a small view of our terminal user interface. If you want a quick view of your workflow, this thing is great. This is showing re-triggering of tasks. So this task bar and this family of tasks in this cycle point. Don't worry about these details. Again, we'll show you later. It's just submitted a second job and now a third job. There's a little radial progress bar for the task. And now we're going to stop the workflow. Now, yeah, I will demo this later, so hopefully it'll be clearer what's going on. So, workflow configuration in Cylc. We have a human-readable text config file format. That's super important because workflow configurations, particularly if they start to get more complicated, should be treated like program source code. And it's very easy to write small workflows and understand them at a glance. So here's Hello World as a Cylc workflow. Basically, we have a scheduling section at the top where you specify a dependency graph. Here, there's a single task called hello, and it doesn't have any dependencies. And R1 means run once. It'll become clear later why that's important. But basically, we're running this trivial graph of one task once. And under runtime, we define what the task hello actually does. And here, what it does is it runs the command echo with this command line. Now, how this works behind the scenes is Cylc generates a bash job script that runs your configured commands in a configured environment, the environment you want it to run in, and on the host you want to run on via the job run you want to run it by, which would likely be Slurm on the NeSI machines. But it has sensible defaults. So if I don't give it an environment, it'll get the default environment, and it will, I don't say how to run the job or where to run it, it's going to run this command as a background job on the scheduler host. Okay, now the job script generated by Cylc is a bash script. So in fact, this is a snippet of bash scripting, and you can use multi-line bash scripting here inside a task if you want. However, that does not dictate what you write your tasks in. Typically, you would execute some external command, and in this case, a Python program in command line. So now to show this dependency graph, we now have two tasks. Goodbye triggers if the task hello succeeds. And this is what the task goodbye does. It runs this Python program. Now, if you want to specify environment for your task at runtime, you do it like this. Specify the platform you want the job to run on. You do it like this. Look at the NeSI support page for more details of this, but basically if you're using Slurm on Mahawika, you do this, and you give whatever Slurm options you need there. You can do things like tell your task to retry after a series of intervals or delays. That says 5 delays of 60 seconds. If the task fails, we'll retry on that time schedule. Cylc has an extensive event handling system. Again, we're not going to see any more of this today, but you can do things like run an arbitrary executable if a particular task or group of tasks or all tasks fail, to do whatever you want. The default triggering in the dependency graph means trigger the downstream task if the upstream one succeeded. But you can also trigger off failure or job submission, or finish means succeed or fail. It doesn't matter, trigger bar either way, as long as it finishes. You can trigger off a family of tasks all at once. So this means foo is going to be a whole family of many tasks. If any of them succeed, I'm to trigger bar. And there are various other ways of triggering off families. So I'm just running through all the options here. You can also have custom outputs from tasks that trigger other tasks. And optional graph branching. So this says the task foo can generate the task X, but doesn't have to. The output X or the output Y. If it does generate output X, we follow this path down the graph. Otherwise, if it generates output Y, we follow this path. Now, don't be scared off here. This is as bad as it's going to get in this webinar. This is a complete workflow definition that shows you how to co-opt 3 separate applications into a Cylc workflow and actually have the data exchange between the tasks very easily, which is what I haven't shown you yet. So let's say get data needs to run just concentrate on the highlighted bit here. Get data needs to retrieve some data, and another task needs to convert that data, and another task, put data, needs to put it somewhere. Well, here in the root environment, runtime is actually an inheritance hierarchy, and root is the base of it, and all tasks inherit these settings. So I've defined environment variables as file system locations under the Cylc run directory, which you get access to via this variable Cylc workflow share directory. 2 file system locations, data and conv. Get data happens to write its output to standard out. The retrieve task does. So we just pipe it. This is nothing to do with Cylc, it's standard bash. Pipe it to this data file. Then the convert application happens to be configured via environment variables for its inputs and outputs. So we tell it these locations here. Read in the file $data, which the previous application wrote to, and write out this one. And then the final application happens to be configured via its command line, an option, and we tell it the shared data location like that. So that's a complete runnable workflow given these three applications. So what's it look like to run a Cylc workflow? Typically, you define your workflow in a source directory under Cylc-source, although you can keep it wherever you want. After working on it, you'd validate it to check for errors before you run. Then you might graph it to visualize it. Then you type Cylc install to install a new instance of it. And by default, Cylc's going to install a new labeled run of it, of your workflow under the run directory, run 3 here. And why is that? That's so you can continue working on your workflow source directory and testing new versions of it while your original is running in production mode or whatever. Then Cylc play is how you start running it. It's a sort of tape deck-like model where the play command will either start or restart or unpause a workflow, depending on whether it's been run before or not. And you can do things like, with our command line, trigger all of the tasks starting with the word model, sorry, all of the workflows starting with word model, all of the product tasks in those workflows that are in a failed state, let's trigger them all manually. Perhaps because they all got killed when the job host went down. Then you can start your GUI to monitor and control it. You can stop your workflow from the command line, and you can clean up. So I've showed you the basics. Cylc has the power to scale up to pretty horrendously complex workflows if you need it, that look like this. This is a real workflow. But I'll just show you how easy it is to scale up for simple use cases if you need to. Point is, you can start small and learn how to do things by playing around and then scale up very easily. So as an example, let's say I have 100 data sets and I need to process them and compute aggregate results. Well, what I would do is I'd write a simple pipeline workflow for one data set, parameterize the processing tasks. I'll show you how to do that, and then just whack the parameter up to 100, and bosh, you've got your workflow to process the whole lot automatically. And when you do that, Cylc will process as many data sets as Slurm allows, i.e. as the external resource that you have access to allows, all at once until finished. So here's an example pipeline for a single data set. Let's say we have a model called sim and a post-processing task called post, and some task that initializes a model run, another one that generates products from it, and then we've got some global preparation task and some global tidying up task, and that's our pipeline. Run once again in the scheduling section. Cylc graph will visualize it like that. And I've omitted the task definitions under runtime, because for this purpose, it doesn't matter what they do. This is actually a runnable workflow as is, without any task definitions. So it will just run dummy tasks. You can use that to understand how the system works. Now let's scale up to 3 runs, say. What I'm going to do is parameterize the model and post-processing tasks. So I've added a parameter definition here, goes from 1 to 3, would be 100. And each of these runs takes the parameter value, and the same with the task definitions. And those parameter values will be passed to task environments so that the actual running jobs can know which data set they're going to process, say. So by simply adding 2 lines essentially to the workflow definition and adding parameters to the right tasks, you scale up like that, 3 runs. Now let's say I want to scale up even further, and each of these runs should run 3 different models with post-processing per run. Well, I can just add another parameter, ABC, and the model, sim, and post-processing tasks get that parameter as well. So you can see now I've got 3 runs of each of 3 different models processing, and really the workflow definition is hardly any more complicated than the original linear pipeline was. Just to show you can do it, you can trigger individual things off individual tasks of individual parameterized tasks here. So I've run a task called check. It's going to trigger off model B of each run, and that's the screen one here, and you can see that's what it's doing. You can also use programming logic inside the workflow definition via the Ginger 2 template processor, or another one we support. It's essentially Python encapsulated in these curly brackets. You can do things like all the usual programming constructs, loops there. In this case, I'm generating lots of tasks as an alternative to the parameterization I just showed you. You can even import Python modules directly and use them, as I've done here. That generates this workflow. Well, don't need to worry about the details. It's using the imported ittertools function called product to combine these 2 different lists to generate tasks. And I'm not going to spend much time on this because I want to get to the demo, but just to say that the runtime section here is not just for individual task definitions. It's a family hierarchy, and that allows you to share workflow configuration, so that even in a complex workflow where you have lots of related groups of tasks, you only need to define any particular setting once. That's important for efficiency and maintainability and so forth. Now, the last thing I'm going to show you before the demo is Cylc cycling capabilities, which I've called the ultimate scale up. And why is that? It's because with cycling is a dynamic way of iteratively processing things, and it's unlimited, a bit like if you're familiar with Python iterators versus concrete lists, say, you can keep going forever. So let's say I've got a small workflow on the left, and then I want to run another copy, run it again, second cycle, and a third, and so on. In this case, I've got dependencies between cycles, which Cylc can handle, but you don't have to have those. There are no dependencies. Cylc can run each cycle concurrently. And then we throw away those cycle boxes, and Cylc sees this as a single monolithic non-cycling workflow composed of repeating tasks. And that allows us to run these workflows without any barrier between cycles. And as I said, that can carry on forever. So you could, with a very small workflow definition, essentially just defining this thing on the left, you can process 1 million data sets if you want. Here's an example of that. So now I've got run once, a prep task, and then a model task. Now I've got a second line on the graph here, P1, which says each model task should depend on, this is integer cycling, the previous model run an integer interval of 1 away. That's what the minus P1 means. So it's depending on its previous instance. The graph is only showing the first 3 cycles here. Then, after every model, I want to trigger 2 processing tasks, X and Y, here and here. And then just to finish things off, after each of those, in every cycle, let's trigger some product, X1 and X2 and Y1 and Y2 tasks, okay? So that's how easy it is to create a fairly complex cycling workflow. I'm just going to show you what you can do at runtime with this. So you type Cylc play demo. Cylc's going to start off by triggering this task, which has no upstream dependencies. And then as each task succeeds, the workflow is going to trickle through your graph like this. And you can see here we're running tasks from 3 separate iterations all at once. Now, let's say you get to here and realize that a file was corrupted on disk and back here, and you need to regenerate these products. Well, while your original front of activity is running through your graph, we can go back and trigger this task with this command line. So I've done that. And now we've got the original workflow still running through the graph down here, and we've started a new flow within the workflow back here. And as that finishes, it will trickle onto its graph, which naturally peters out here. And then if there are only 3 cycles, now we're finished. So that's just a little demo of how cycling works to iterate through data sets, say, or model runs or whatever in Cylc, and also the use of multiple flows within a workflow, which is new in Cylc 8. And time for the demo. Yeah, so hopefully what you've seen is for simple workflows, it's very easy to write and understand them in Cylc. Hopefully I haven't blasted through too many details to dissuade you of that. But also I've shown you how to scale up pretty easily to bigger use cases.
I was wondering if we should have just a little 1 minute pause if people have any questions or comments or anything.
Yep.
Yeah. You can speak out up, or you can post your question in the chat box.
All right.
No, one of the things I just wanted to say, and it's one of the most significant piece of software written in New Zealand, Cylc. So I think we really privileged here to have Hilary present not only a software, but actually the software that he designed from the scratch, and which is used by number of laboratories around the world. Here comes a question from Errol. So the question says, how do you schedule to run, say, every 10 minutes? Can you trigger some tasks, at particular times?
So I haven't. I've concentrated on non-cycling workflows as an introduction here, and then some integer cycling for just general iterative stuff. But if you want to actually connect your iterations to the real-time clock, which I guess what Errol's asking, then Cylc can do arbitrary date time cycling instead of integer cycling. So instead of an integer cycle, you can define any sequence of date times every 10 minutes if you want. And then you can add a clock trigger to tasks that tie the cycle point of the task to the actual real-time clock. Now, this is a bit different to using cron, say. It's more powerful than cron. It's more general, because in a Cylc workflow that is tied to the real-time clock, if it gets behind because something went wrong, it can catch up as quickly as possible, interleaving cycles according to dependencies and resources, until it's caught back up to the real-time clock. So it doesn't always just have to run every 10 minutes. If you started a week in the past, say, it's going to go as fast as possible until it catches up to now, and then it will start being constrained by the 10-minute clock. So that's how you do that.
But is that optional though, Hilary? Like,
yes.
if you don't want it to catch up, it'll just wait for the next 10 minutes, say.
That's a yes, you can do that. I don't think I have time to go into the details here in this seminar. So
no, it's just knowing that it can do it.
There's also a question by Alina. Alina is asking whether if your model sort of hits the 24-hour NeSI time limit and stops, can you sort of restart the model?
Yes. Hopefully, if I get time, I'm going to demonstrate in the demo this. Another advantage of using a workflow system like Cylc is if you're running your workflow, however complicated it is, and then you stop it or it gets killed. Well, let's say you're running one of NeSI's interactive Slurm sessions and you run out of time and Slurm kills your workflow scheduler and all of its jobs. Well, that's no problem with Cylc. You just, when you get your next session, you just type Cylc play workflow nav again. It's going to come up in exactly the state it got to when it was killed or when you shut it down or whatever. And you just carry on from there. If there were failed tasks in it, it's going to come back up with those tasks showing in the failed state. And if it was failures were caused by a machine going down, well, you just re-trigger them. If it was caused by a bug in the task, you fix the bug.
But she could also, I mean, if she saves a checkpoint file, then you know, maybe she wants to restart the model slightly differently from the first time she ran or something. That's also possible, right? I mean, if you have a failure, then you can run again you know, using a slightly different sort of command line argument or something.
Oh yes, if you're just talking about a model failure as opposed to the whole workflow going down, then let's say you have a model that has a known failure mode, and if it fails in this way, you can rerun it with some different switch or different parameter or something that will perhaps make it succeed, but it might take a bit longer or whatever. Then you can configure Cylc to trigger a different path if this failure happens. And you know, you'll have the model fails, so you have a task that diagnoses the failure. If it was this kind of failure, then we go down this path in the graph to recover and then carry on as normal after that.
Excellent. One more question perhaps before we go to the demo from Sung. So he says, can you run the GUI locally? And maybe you're going to do a demo of that, but just a quick question. Is it something that runs remotely? I guess it's on the web,
yes,
right?
I'm going to demo that. Because the Cylc UI is a web UI, it is served, if we're running on a NeSI machine, it's served from the NeSI machine, but you run your browser, the UI runs in your browser running locally.
Excellent.
So yeah, I'll show that.
Should we go on and start with a demo? Yeah, excellent, thanks.
All right, let's do it. Okay, so I am on Maui, could equally be on Mahuika. I'm on one of the interactive nodes that I have access to in this terminal. And I am in, a source directory called NeSI. And this contains a workflow, small workflow source, some files, including some Python programs in a bin directory and a workflow definition and some other files. Okay, so I'll just show you the simple programs that I'm going to co-opt into a workflow. This is based on a sort of extended Hello World example, and again, Cylc doesn't care what you're running in the task, so it doesn't matter that these are trivial. It works just as well for any real job. So this is the first program. It's simple, but don't worry about the details. Basically, retrieve current list of worlds in the solar system from NASA. And here's a class called NASA, and it prints those worlds to a file that you give the name of on standard out, and it prints that list in JSON format. Done. That's the trickiest one. The next file, the next program called choose world, reads a JSON list on standard in, and chooses a random world name from it, prints it to standard out. And finally, this hello world program says hello to the world name it receives on the command line. And I want to turn that into a workflow. So here it is, my workflow definition. Okay, so we've got get worlds, choose world, hello world, and a final task called report. bit like the example I showed you in the presentation, under the root environment, which all tasks succeed, I'm just defining these files to use for passing data between tasks in the Cylc workflow share directory, which is automatically provided to you in the run directory. Now you can use any old directories you want, of course, but I'm just using the convenient share space provided by Cylc. All right, so get worlds runs the get worlds program, and it says, remember that program took the output file name on the command line, so I'm using this one. Then choose worlds reads that file in on standard in and pipes it to the output file called chosen there. And again, this is nothing to do with Cylc. This is just using bash scripting to manipulate files and output streams and so forth. You can do it however you want. It's about flexibility. And finally, hello world says hello to the world that's been written to the file called chosen. So we're defining these variables so that we don't have to repeat the definition of each file in each task. And yeah, the report then counts how many greetings were made. In this case, only one, because it's a linear pipeline. Okay, so there's my workflow definition. I'm going to install it. Cylc install. Actually, first I'll validate it. Cylc validate. It says it's valid for Cylc 8. Now, if I had made an error in the workflow definition, it would have been reported there, and I can fix it. So it's all valid, so I'm going to install it. So here we are, it's installed NeSI/run2, because evidently I already installed a previous version. And let's look at what got installed there. My Cylc run directory, NeSI/run2. So you can see all of the workflow files have been installed into the run directory. If I installed it again, it would install a copy called run3. I could run them both at once independently if I wanted. Right, let's run it. Cylc play NeSI. Now, if it's the latest run, I can just say NeSI. I don't have to say /run3 or 2, but I can if I want. If I want to run an earlier one, I need to do that. And I'm going to tell it with this -n option not to demonize, so it's going to stay attached to the terminal, and we can see the output from the scheduler. And this is going to run quickly because these tasks don't do anything that's very computationally intensive, as you saw. So that's just the scheduler saying, this task is ready, I'm submitting it to run, this task is running, now it's succeeded, blah, blah, blah. You often won't need to look at the scheduler log, but if you do, the information is there. So now let's look at the run directory again. Let's look just 2 levels deep. Now I can see in my run directory, there's this share directory where the data that we told the tasks to, the files we told the task to use is in there in the share directory. And I can let's print them all out. You can see here's the list of all the planets from NASA and the chosen one, and we said hello to it there. All right. Now let's look at the job log directory. So each of the tasks that got run generated a job log directory where we've captured the standard output and standard error and some other information. Now, if you want to look at the logs from your job, you can go straight to the file system here. Let's look at report, which sort of counted the number of greetings we made, which will only be 1. Okay, you go straight to the file system, look at that, it counted 1 greeting, and there's some boilerplate information about where the task ran and what it was called and stuff, and then what workflow it was running in. Or you can use the Cylc catalog command, NeSI 1/report. So you don't need to remember where the file is located. Or you can use Cylc Review, which is a web-based log reviewer, which I'm not going to demo today because I'll run out of time. Now, I'm just going to copy in a modified, scaled-up version of...
Just a quick question,
Yep.
Hilary. There's a question from Jan, and he's asking whether if your tasks are very small and don't take a lot of time, I mean, can Cylc actually group, some tasks and so to when submitting to Cylc, so in case you have thousands of short-running tasks in a workflow, can Cylc group them together to reduce the number of total jobs submitted, or is this not necessary?
Yes, Cylc has an internal queuing system that you can use to restrict the number of jobs that become active at once, even if they're ready to run. So if you're in danger of overwhelming the system, you can do that. In fact, I'll demonstrate that for the web UI demo. All right, so this is hardly changed from the previous version. All I've done is put a random sleep in to slow every task down. Prescript is just another piece of bash scripting that goes in the job script before the main one. And I have added this parameter m, which runs from 1 to 5. So this is very much like the example I gave in the seminar, and I've parameterized the choose world and hello world tasks. So we still retrieve one list of worlds, but now we're going to choose randomly 5 of them instead of just 1, using different tasks, and say hello to them all separately, and then finally the report's going to count how many we did. And then all I had to do to use these parameters was make the parameterized task definitions know the value of their parameter m, and I'm saying write to a parameter specific data file instead of the general one. So chosen now becomes chosen.1, .2, .3, .4, .5, okay? If choose world M1 is going to write to chosen.1, and hello world M1 is going to read chosen.1 and write to greetings.1, okay? So let's install it. Let's run it. This time I'm letting it demonize. It runs in the background, so even if I log out, it's going to keep going if I'm on interactive mode. Now, how can I see what's running? Cylc scan. It's going to tell me I have this NeSI/run free workflow running. That can supply richer information. Or we can crank up the terminal UI and see what's going on. Okay. This has a help screen showing you what the various task and job icons mean and so forth, but you can see basically what's each task is doing, what state it's in. That's what the colors mean, and the workflow's finished already. I'm just going to install and run another copy of it so we can see a bit more on the terminal UI. So we're running out of time. I've got to, whoops. Just installed another one instead. Run 4. And drill down to job details. I can kill jobs using this little menu. I can re-trigger them. All sorts of fun things like that. Okay, now what I'm going to do is put an error in the job implementation for task implementation. I'm going to misspell the name of the application I want to run in the choose world task. So if I install this and run it, play NeSI, all of the choose world tasks are going to fail because of that. So let's see if they do. Oh, here's one that's failed after its random sleep time. And they're all going to fail. So what I can do is stop this workflow Like the tasks have failed, the workflow hasn't. It's still, the scheduler is still running. It's just reporting that these tasks have failed. So I'm going to stop it. That's stopping the scheduler. And I'm going to look at the logs of one of the failed tasks to see what went wrong. So, oops. Cylc cat log. What's it called? Choose world into. So you can see that task started running, but it never reported finishing. Let's look at the standard error instead of standard out. And there we go. Chose world.py command not found. So I spelled the program name wrong. So now I'm going to fix the bug. Chose. There it is. Is the culprit. It should be choose. By the way, if I have executables in a bin directory in the workflow source directory, tasks automatically get access to that via the environment at runtime, but you can of course run commands anywhere on the system. It's up to you. Okay, so I fixed that. Now I'm going to reinstall the workflow. So instead of installing a new copy, I'm installing the changes from the source directory, and now I'm going to play it again. It's going to start up where it got to before I shut it down. So let's look at it in the terminal UI. And there it is. It's running again, and it's saying these tasks failed. But now, because I've fixed the bug, if I trigger that task again, boom, it's going to submit job number 2. And this time it's going to succeed. Blue is running and green is succeeded. So when it finishes its random, there it succeeded. Oops, well, that's what I wanted. My other pane. Let's keep looking at that. I'll show you on the command line how I can sort of trigger NeSI //.1 choose star in the failed state. So I'm going to trigger all at once all of the tasks in this workflow that are that start with the word choose, the names start with choose, and are in the failed state. So I'm going to hit that, and boom, there it goes. They're all going, and now they're all going to succeed, and the workflow can carry on downstream of that and run to completion. All right, as a final demo, I will copy in a slightly more complex, again, version and show you the web UI. Only about a minute or so over time, so hopefully people are fine with that. Apologies for going a little over. All right, so now the workflow definition. It's almost identical, except that I've changed R1 to P1, so that, which is short for run indefinitely from the initial cycle point on a period of 1 on integer cycle. So it's now going to run an indefinite number of copies of this parameterized workflow. I've also added queues, like we mentioned before, to prevent overwhelming the system. It's going to run a maximum of 5 tasks at once. And I've also added some stuff that calls random failures and automatic retries, just to make life more interesting in the UI. So Cylc install. Cylc play NeSI. And I'm going to crank up the web UI from this other terminal. Cylc GUI. So this is this terminal is running also on Maui, and it's starting up an ad hoc web server with a secure token, and it gives you this URL, which I'm now going to open in my own browser, which is running on my desktop machine, not on Null. And what's going on there? Something's got to go wrong in the demo. Oh, here we go. Here it is. So this is the Cylc web UI. You land on a dashboard page. We can reach the online documentation directly from it. On the left here, it's showing all of my installed workflows and the fact that this is the one we're running. You can filter in various ways here if you want. I just want to see running ones. There we go. You can filter by name, demo, NeSI. Anyway, let's click on the running workflow. Oops, turned off running workflows. There it is. Sorry. I accidentally clicked on this link here. All right, so now I've opened a view of the running workflow. And you can see a lot of tasks there. Some of them are in the queued state. That's due to the maximum of 5 active tasks I see. These ones are ready to run, but they're in the internal queue in Cylc. It's not the slewing queue. And again, we can drill down to job details. See that one random succeeded. I could trigger that manually, trigger another. It's going to submit another job. Oh, it's queued. I'm going to trigger it again to get through the queue ahead of time. So here we are. That task is now submitted and finished. A second job. Here's one that failed its first job, failed its second job. You can tell it's retrying because this monochromatic icon says and the task is in the waiting state, but it's got failed jobs. That means it's going to retry. And here it is retrying a third time. What else can we see? We've got any hello jobs going yet? Not yet. I'm going to trigger one ahead of time to show you something else about these jobs.
So we do have a question, Hilary. I'm not sure if while the piece is running or should we wait? Okay, so a question by Daniel, and he asks whether can one flow.cylc call or include another? So basically a nested workflows.
Yes. Yes, you can run workflows inside of the tasks in another workflow. That's kind of a tricky thing to do. If you're interested in doing that, you need to get in touch with me. But you can do it. So now I've opened another view. So in this view, we can just show the active tasks: preparing, running, submitted, or failed. Let's say failed. So it's not showing any failed tasks because these are only failed jobs. They haven't actually, the task hasn't failed yet because these jobs have configured retries. But this is just to show you can have different views of your workflow as it's running. You can filter by name. So this new UI is something of a work in progress. We don't yet have a dependency graph view like the old Cylc 7 UI did if you're desktop UI, if you ever used that. But that's one of the first things that's coming, will be that. So the idea is that if you've got a complex workflow, you want to be able to drill down and see exactly what's going on in it, and intervene in its operation if you need to, or just monitor it. At the moment, we have this collapsible tree view, and we also have a table view that has all the job information arrayed out horizontally like that, and this is also paginated. Show them all like that. And you can also drill down to job information, particular jobs in this table view. So this particular task, choose world M3, it's now running its third attempt, having had 2 failed jobs. All right, so obviously in this short webinar, there's only so much I can show you. I've hopefully given a good impression of kinds of capabilities are available. Perhaps the very last thing I should show is just what's happening in the log directory of this more complex example. Cylc run NeSI, run N always points to the latest one. And I'll just do directories. So you can see we've run an awful lot of jobs already, but they are all laid out in a very sensible, easy to find location. And if you use the Cylc review job log viewer, you can easily browse thousands of job logs if you need to. One other thing I forgot to tell you, if I just look at the directory, Cylc run directory at the top level, this NeSI thing here, you can see that Cylc install has automatically symlinked the home directory location, which is the sort of standard location. You can easily always find your workflow logs and so forth. It's symlinked it to my project directory location, where I can store loads of data. So that's done automatically so long as you have projects set in your environment. And I'm going to stop all of my workflows. There's only one, so it's going to stop it. And incidentally, to clean up after running workflows that you finished with, you just use the Cylc clean command. So I'm going to say Cylc clean all of my runs of the NeSI workflow. That's going to follow these symlinks and clean up the actual data locations. There's various ways you can clean. You don't have to delete everything. It would also go and go to remote job hosts, if I was using any, and clean up on remote hosts, because Cylc knows about clusters. So there we go.
Hey, thanks, Hilary. That's fantastic. I think one thing that came out of your demo is, when I started, I talked about one particular application where you have this calibration or parameter studies, and you're running all these jobs, and then you do some aggregation at the end. But I think through the demo, I'm starting to realize, how much more powerful Cylc can be in terms of a tool to restart models. And we're having some questions from Alina, for instance, and she's asking, can one get a consultancy, NeSI consultancy, to put models into Cylc? And my understanding, maybe Alina, you may want to talk about it, but it's the model fails. Maybe you want to re-trigger, another execution under slightly different conditions. Maybe reading a checkpoint file or something like that, or change the parameters. Is that what you have in mind, Alina? You can turn on the mics if you want to.
Yeah, we're doing future projections of the climate, and these are jobs that just constantly need a restart and then spend 6-7 hours in a queue regularly. So just to take off that pressure of constantly checking your emails to look if your job has failed, and knowing that it will restart and find the latest checkpoint of models and go on, and we can essentially not look at it for a week. That would be awesome.
Yeah, well, you can, in terms of long-running systems like that, you can with Cylc, you can do all sorts of fancy things, like have it email you if you're away on the weekend or whatever, if one of your jobs failed, as well as setting up automatic resubmissions if that's appropriate for the kind of job failures you've seen.
Yeah, we just ran out of time limit.
Right.
I understand. I mean, Alina, because in some sense, the user has to determine the resources ahead of time, and sometimes it's really hard to know, how long the run is going to last, how much memory is going to be required, and so can we think of Cylc as being also a tool, to resubmit automatically, maybe with a higher memory requirement or a longer time limit, or in the case of Alina, I think she's hitting the 24-hour limit, whatever the reason is.
Right. So if your model does checkpoints that can be restarted after that limit, then you can certainly have Cylc arrange the resubmission for you to make it restart from that point. I mean, the thing about a workflow system like Cylc that I think is most valuable is if you've got a workflow, some series of jobs that you have to run, you never are going to have to go back to the start and start from the beginning again if something goes wrong. Even if the machine went down and killed everything, you can just start again from the point in the workflow that you got to before it all went horribly wrong. So you can save a lot of time and effort by reducing that kind of repetition.
Do we have any more questions or comments before we move on?
Oh, I had one, sorry. If there's an input file, let's say to a process or the whole workflow, and that changes, is it smart enough to know that it needs to rerun that, that the cache is invalid or whatever?
It doesn't, well, are you talking about files in the workflow source directory, say, or something to do with inputs to the workflow?
Yeah.
Right. It doesn't, by deliberate design, we don't do that automatically because you don't want things to change when you're not aware of it, right? But if you make changes in the run directory, or you make changes in the source directory and reinstall it into the live running workflow directory, then you can tell the scheduler to reload the workflow definition while it's still running. So you want to do it deliberately though. And in terms of scientific repeatability and provenance and so forth, Cylc keeps track of all that for you. Every time you do a reinstall or a reload, Cylc records that you did it and what changed. And if your workflow source is a Git directory, a Git repository, which it should be, then in the run directory, there'll even be recorded the Git status of the source directory compared to the run directory every time you make a change. So you should end up with a more or less complete record of what you did throughout the run of your workflow.
But in the case, let's say, if I understand well what Daniel's situation is, let's say you something that is event driven. So you have a file and now a new file comes into the directory because you have sensors or you have some automatic sort of measurement system, something like that. And at which point you want to trigger essentially the workflow again with those new data. Is that a little bit what you have in mind, Daniel?
Yeah, well, that'd be one. I guess the other situation is if you have a workflow, let's say you want to experiment with some different configuration for different parts of the workflow, and you go change some config files, and then you would ideally rerun it, and only those processes that have new configuration and anything downstream of them would rerun, and you wouldn't have to manually trigger them, I guess.
Oh yeah, well, Cylc 8 is great for that. And in fact, I don't know if you can do this sort of thing in any other workflow system at the moment. I showed a little bit of it in that final semi-demo in the presentation, that you can in Cylc 8 you can trigger a task manually anywhere in the workflow graph, and the workflow will trickle on from there as dictated by the graph. Even if you're already running your original flow in that graph, you can trigger other tasks. So if in your case you want this particular subgraph to run again because you changed some stuff, just trigger the top tasks in that subgraph and it'll just happen. Yeah,
that manual thing is quite neat. I use Nextflow, and I don't think that has that option. It is also helpful to be able to do it automatically sometimes as well, so it can understand where it needs to change, where it needs to rerun without you having to do it manually.
So for that in Cylc, if you were writing a workflow where you knew that sort of thing was necessary, what you would do what I would do is essentially have a task or an external trigger that watches for those changes, and then it triggers the new behavior on a change. So it's not sort of built into Cylc, but it's easy to do, to roll your own ways of doing it. Like you can have a Cylc task that uses the Cylc command line to interfere in its own workflow. So here's a particular task that's watching this directory and sees something changes, so it triggers another piece of the workflow again.
Yeah, cool. Thanks.
Thank you so much, Hilary. One quick question, because we're already, I think, 18 minutes over time, so we might want to take one more question. No, it's okay. You at least you took the time to answer all the questions in between your presentation, which is quite difficult to do. Alice has a question. Can we choose different machines for different parts of the workflow if parts are running on GPU and other on CPU, for example?
Yes, absolutely. You can, within a single workflow, you can choose, you can put different tasks on different machines, different platforms, or you can supply different Slurm options, which will determine whether or not this task runs on a GPU or this one runs on a CPU or whatever. That's built in from the start with Cylc.
Does that answer your question, Alice? Or did you have any additional comments or?
No, thanks. That's perfect. Thank you.
Okay, awesome. Well, thank you so much for everybody who stuck on and stayed with us. You will receive an email from us very soon. Please do take the time to go through the feedback form, and I will also include the recording for this session in case you want to go back and check any parts of it. So thank you so much. Hope you have a wonderful day.
Thanks, everyone.
Thanks, everyone.